Today we are going to learn how to simplify radicals. I am looking at the notes that are currently uploaded to Google Classroom, so you can follow along with this if you split screen your iPad to fill in the notes as we go through how to do these problems. Step 1 is to factor each number and expand each variable. The calculator command we are going to use for this is factor. You may find it in the menu and number submenu, or you can simply type in the word factor using the alphapad. So using the calculator to type in the command factor 6561 in this case should give you 3 to the 8th power. And when we expand this means I'm going to have to write the number 3 8 times. The order or the shape of these 8 do not matter. We just need a list of 8 threes. In this case, I simply decided to write these as 2 rows to save space. Next, I will tackle my variables a and b, which will both be written as many times as their exponent indicates. So an a to the 6th will be written 6 times, and a b to the 4th will be written 4 times. So the end of step 1 looks like this. I have used a calculator to factor out 6561. That resulted in 8 threes. I have written out and expanded my variables, so I have 6 a's and 4 b's. For step 2, we are going to be creating groups of these numbers, and the size of the group will be indicated by what is called the index of the radical. That is the number in front of the radical sign. So please remember, in the case of a square root, that invisible number is 2, and for every other root, we will see the number that we are going to be using. Cube roots use the number 3, fourth roots use the number 4, and again, this is going to tell me how many of a kind I need in order to complete a group. In our example, you can see the number 3 indicating this is a cube root, and that I will now be creating groups of 3 of a kind from all of the numbers and letters that I have. The end result looks like this. I have 2 sets of 3 threes, 2 sets of 3 a's, and 1 set of 3 b's. The last step is a skill that we have seen before. It is that we will write each group once outside of the radical, ungrouped numbers inside, and the note that we need to make for this particular process is that the radical does not change. So that 3 that I had for a cube root will still be there at the end of this problem, unless, of course, there's nothing left inside for it. So as I start to write my answer in orange, I have started by writing this cube root, again being very clear that this 3 is part of the radical. From here, I'll be writing each of my groups outside, so a 3 and a 3 for each group of 3's, an A and an A for each group of A's, and a single B for my group of B's, while my remaining letters and numbers will be inside. The 2 3's and the B that are not grouped are what will be inside. So once again, each group is represented once outside, so that entire group of 3 threes created a single 3, and I only have 2 threes there because I had 2 groups. So it's not the numbers inside the groups that count, but rather how many groups were made. So to clean this up for a final answer, I will be multiplying each of the things outside together, making a 9a squared and a b, and multiplying the inside pieces together, making a 9 and a b. And I'm also very careful to write that 3 as part of the radical as separate from the b, so that it does not get confused as a power of b, but rather stays the index of that radical. So quickly back through the entire process. We used a calculator to factor our number and expanded our variables by writing them out as many times as their powers indicated. We created groups based on the index, so in green where that 3 is circled, that is why we made groups of 3. If you have a square root, you'll be looking for pairs of numbers. If you have a fourth root, you'll be looking for sets of 4. And after these groups were made, each complete group was represented once outside of the radical, which did not change. Leftover things that were not grouped were represented inside of the radical, and we simply multiplied to clean up our answer after that. If you have no groups remaining inside of the radical, you do not need to keep the radical there. And if you somehow randomly get the same letter in your problem, then be sure to combine as many groups as you can across both of those sets. Good luck. Bye-bye.